Hello, today I have to revise a lesson in Maths which is application of differential calculus. So, in this lesson, I'm going to learn all the topics, examples, exercises, theorems, and all those things in this lesson. There are like 10 subheadings in this lesson: meaning of derivatives, mean value theorem, series expansions, indeterminate forms, applications of first derivative, applications of second derivative, applications in optimization, symmetry and asymptotes, sketching of curves. So there are 10 exercises also here in this lesson, and I'm gonna do all the exercises and examples from today. Let me see how much long gonna it take. Derivative a slope. First let's see about slope or gradient of a line. Slope or gradient of a line. So let L be any given non-vertical line. So this L is a non-vertical line. Means a straight line which is non-vertical. So taking a horizontal line segment of any length with a starting point in the given line L. Taking a horizontal line, this is the horizontal line of any length with a starting point in the given line L, and a vertical line segment starting from the end of this horizontal line to touch the given line. It can be observed as the ratio of the vertical length to the horizontal length is always a constant. The ratio of the vertical length to the horizontal length is always a constant. This ratio is called slope of the given line. This ratio is called the slope of the given line and is denoted as m. So this is the slope or gradient of a line. And the slope can be used as a measure to determine the increasing or decreasing nature of a line. Listen, the slope m can be used as a measure to determine the increasing or decreasing according as m greater than 0 increasing or m less than 0 decreasing respectively. And also when m equal to 0, the value of y does not change. When m equals 0, the value of y does not change. Why? Because see, y equal to mx plus c is a equation of a straight line. So when m equals 0, substituting m equal to 0, we got y equal to 0 into x equals 0 plus c. So when m equal to 0, there also exists another number which means y value does not change. So here y equal to mx plus c represents a straight line in the xy plane where m denotes the slope of the line. Slope or gradient of a curve. See, first we saw about slope or gradient of a straight line. Now slope or gradient of a curve. So let this curve be y equal to f of x. Let y equal to f of x be a given curve. The slope of the line joining two distinct points x comma f of x and the point x plus height comma f of x plus height. See, now in this curve x comma y is a point, right? This point is x and y is f of x. We can also take this y as f of x. See, y equal to f of x, x comma f of x, the point. And also this line is a tangent to the curve, because tangent is a line which touches the curve at only one point. If it touches at exactly 2 points, then it's known as secant. So How to find a slope of a curve? Slope of the line. See, slope of the line joining two distinct points x comma f of x and the point x plus h comma f of x plus h is f of x plus h minus f of x by h. y2 minus y1 by h. It's known as Newton quotient. So, Newton quotient is the slope of line joining two distinct points x comma f of x and the point x plus h comma f of x plus h. So, slope or gradient of a line, the slope of the line joining two distinct points x comma f of x and the point x plus h comma f of x plus h is f of x plus h minus f of x by h, Newton quotient. So while taking limit to this function h tends to 0, taking limit as h tends to 0, we get limit x h tends to 0 of f of x plus h minus f of x by h equals f dash of x. So this is known as limit of Newton quotient, which is the slope of the curve at the point x comma y or x comma f of x. Listen, Newton quotient is the slope of the line. Limit of Newton quotient is the slope of the curve. So in order to find the slope of the curve, first we have to find the slope of the line, which is f of x plus h minus f of x by h, and after that, taking limit to this function, we can find the slope of the curve at the point x comma y or x comma f of x.